Let's find the domains of two logarithmic functions. Part A, f of x equals 3 times log base 4 of the number x minus 5. And part B, g of x equals log. No base appears, so we understand that the base is base 10. This is a common logarithm. So it's log base 10 of the absolute value of x plus 3. So we see here that x is part of the number portion of the logarithm, the capital N, the number portion. So we're only interested in any type of restriction in the definition of the logarithm that involves the number portion, capital N. Okay, because that's the only place our x appears. Okay, so the only requirement that we had in the definition of y equals log base b of the number n, back in our notes, was that the n value had to always be greater than 0. Okay, so our x's appear in the n value, so we'll have to keep that in mind. In part A, the n value is x minus 5. That has to be greater than 0. So set x minus 5 greater than 0, solve, you get x is greater than 5. So the domain in interval notation starts with 5, but it doesn't include 5. There's no equal portion there, so it's a round bracket 5 to infinity round bracket. Part B, the n value here is the absolute value of x plus 3. But you know, x plus 3 is always greater than or equal to 0. It's never a negative number. So it doesn't seem like we have a problem here, but we do have to make sure of one thing. We have to make sure that it's not equal to 0, because n has to be greater than 0, not greater than or equal to 0. Okay, so we know absolute value is always greater than or equal to 0, but we have to restrict it so this never gives us a value that's actually equal to 0. So we take the stuff inside and say it can't be equal to 0, so it can't be equal to negative 3. Therefore, the domain is the split interval from negative infinity to negative 3 open interval, union together with open interval negative 3 to infinity, open bracket. Okay, so we didn't have a problem with it being greater than 0, because absolute values are always greater than 0. Our only concern was that we cannot let it be equal to 0, because in the definition of the logarithm, the number part capital N can never be equal to 0. It has to always only be greater than 0. So we just set x plus 3 not equal to 0, and we restricted our domain to everything except it can't be negative 3.